Welcome to Lab 8. So the Lab 8 is about the preparation and properties of oxygen. We are working with different chemicals. Those all are complex compound. That means we can see more than multiple elements they are together. So this is called like complex compound. So what we are doing is a complex compound. We are going to heat it. This is the cone for heat. So we are heating it, and then we will see some chemicals, chemical change. That means chemical change means it may change the color, it may change the odor, maybe precipitate forms. That means the solid, insoluble solid, we can find it. It may produce some bubbles. So if you see those kind of changes, that means it has chemical changes. So we will work later on that sodium nitrate, silicon dioxide, lead 4 oxide, magnesium oxide, and potassium chloride. So all these complex compound, we are going to heat it, and after that we will get different compound. So not all of them will do the reaction actually. So the silicon dioxide and the magnesium oxide, we will see that after heating up, we are not going to see any reactions. But the compound, we can see that sodium nitride will produce, which one should be solid, and produce also oxygen gas. In this demo lab, we will show you, maybe we will see some gases will produce, but we will maybe confuse like what kind of gas is it. So to make sure that it's really oxygen gas, we will show some demo that it is oxygen gas. So oxygen actually helps the combustion reaction. So that means it helps to burn any compound. One more thing, those are the complex compound, right? And we are heating it. That means this reaction is decomposition reaction. Also, in these reactions, we will change. So before started heating up, we will see some physical properties, some different kind of physical properties as state of the matter. And after heating up, we will see different state of matter. Maybe it's melted, maybe the color change. So all these things is related with the physical properties. So now we are going to demonstrate the lab. As we are speaking about the decomposition of every compound, so you can see the part 1, it says decomposition of oxygen contained compounds. All those compound I talk about, sodium nitride, silicon dioxide, so all of them has oxygen. So we are going to decompose by heating up. So let's see. As we are going to do the lab right now, we need the safety protocols. We explained it before. So we need the gloves and we need the goggles. Also, whoever has long hair should tie up, because we are going to use the Bunsen burner. We don't want any harm happen to you, because it contains the fire. So let's see. The Bunsen burner, how you are going to use it. There has 2 knobs actually. The bottom part, it actually helps to control gases. So when you do counterclockwise, it actually closes the bottom part. Okay, so counterclockwise is this way, counterclockwise is this way, it's all the way down, so it's already closed. This part helps you to control the air. So this one is counterclockwise, and this one should be the clockwise. So it's already closed. When you handle the Bunsen burner, make sure someone always stay very careful, because it may be fall down and it may cause for fire to catch. So we should be someone should be attendant here to like manage the Bunsen burner. This part you can hold it. It's not going to be hot. So this part, the bottom part should be, you can handle it, but never ever touch this part. It should be heated up. Okay. Here you can see this part is close the gas. Okay, and this way all the way down here, this way the gas is coming up. Okay, so vertical is gas coming up, the horizontal there has no gas, it's already the valve is closed. Okay, so now I'm opening my gas. This one is closed already, I closed it. Okay, I need little bit of gas so that I can turn it on. So I said that the bottom part is counterclockwise. To open it, it should be going to the clockwise. So I can hear hissing. So that means gas is coming up. And this one was clockwise. I will do counterclockwise to open it. This helps you to catch the fire. Okay, now I'm trying to, okay, so now you see from the yellow to blue is coming up. That means I control my air, and we want a blue cone. Okay, now I can see the blue cone. I don't know if you can see it or no. So the inner blue cone actually heated up. Okay, so my Bunsen burner is ready to use. I'm putting it here so that I'm not going to touch it. Okay, next, there has different compound. This one is the sand, silicon dioxide. We have sodium nitrate, which one is white. So the part one, what we are going to use, like first we will see before heating up the physical properties, and then after heating up we will see the changes of physical properties. So the state, so before heating up it was solid and is white. Okay, when you heat up, make sure you use this tongue. Okay, so first one we are using sodium nitrate, which is white and solid. So guys, this is sodium nitrate, right? And as you can see, this is solid and white color, right? So now I'm going to heat it up, and I want to check the physical properties changes or no. Physical properties means the color changes or the matter, the state of the matter changes or no. Okay, so let's see. We are heating up, we are using the inner cone, which one is hot. The outer cone is not that hot. Look, it starts to melt. Okay, in the meantime, what I'm going to do, because I showed you in a reaction that we are going to produce sodium nitrite. So now this time I can see it was solid, white. Now the state of matter change from solid to liquid, right? You can see. The next one I will show you the oxygen. The gas is oxygen or no? Let's try with the lead one. So lead 4 oxide, which is black color, right? And now we were trying to decompose, and also we will see that the oxygen gas produced or no. Okay. So before heating up it was black. Okay. Now you can see a few. Okay. I think you can able to see it. Yes. One more time. Yeah. Now it's producing. Okay. So as it helps the golden wooden splint, it's reignite. So that means it helps to get the fire, right? And that means the oxygen, the gas which one is producing is actually oxygen. Now check. This was total black, right? The starting, and now it's kind of golden, it's kind of orange and reddish color. We get it? So the color changed. It was before lead 4 oxide and now it is lead 2 oxide and produces oxygen. The third one is silicon dioxide. So you can see this is already solid. So actually we can find silicon dioxide is actually the sand. You can find out in the beach. So now I'm heating up and I know that there should not be any reaction. That means no color change, nothing. Okay. Okay, so you see, after heating up, there is no color change. That means no reaction. No reaction for silicon dioxide. Now we have potassium chloride. So potassium chloride, which is solid and white powder. Okay, we will see that what will happen after heating it up. In the meantime, I will try to get the oxygen gas test. The golden splint now is reignite. This is very low amount, so that's why oxygen cannot produce much. but you saw once that is lignite, so that means it's oxygen gas. Okay, so now you can see it's already melted. It's not that clear, it's a little bit foggy, but it's melted. It was white powder. Now the state has changed from solid to liquid. Now for the magnesium oxide, we don't have it actually, but we can make it. This is the pure magnesium, which is shiny, right? This is very shiny magnesium. This is pure magnesium. What we are going to do, we will burn it. So after burning it, it will make the magnesium oxide. Make sure this will produce a UV light, which is very harmful for your eyes. You should not look straight up to the flame, because the flame should be so bright. Okay, so you can see the flame is so bright. I'm not looking at it. I think it's done. There is not too much flame. Okay, so now let's see. Magnesium, the pure element, was shiny, and now after burning we can see that this is white. Okay, so this is now magnesium oxide. There is nothing burning right now, so it's already proper magnesium oxide. As we are done, we are going to close it first. Okay, after you finish your decomposition, always you cannot burn it, you cannot open your Bunsen burner all the time. So make sure you are done. I said that it was counterclockwise, right, to close it. So close it. To counterclockwise. It's already closed. Then you close the valve too. Now we come to the second part, which one is we are collecting the oxygen. What we are doing is we are using hydrogen peroxide, which is in a liquid based. It's usually 35% hydrogen peroxide, and we are using the catalyzed, which one is magnesium oxide. Okay, catalyzed, what it does? Catalyzed is a substance which helps to speed up the reaction. It itself doesn't consume in the reaction, but it helps to speed up the reaction without it consuming. Okay, so we are using the magnesium oxide catalyzed. Then we will produce water, the liquid, and our desired element, oxygen, which should be a gas form. For the second part, we are collecting the oxygen. What we need, as I showed you in the reaction, we need hydrogen peroxide. This is 35%. So hydrogen peroxide, we need only 40 milliliter. Okay, I put it in the beaker. Make sure, I told I think in lab safety, that when you pour it in the beaker, if you have left the excess reactant, don't put it back to the bottle, because I don't know what is inside in the beaker. Sometimes other reactant is inside this beaker and do reaction, and it could be contaminated. So hydrogen peroxide, we need the catalyzed, which is inside in here, magnesium dioxide. Okay, we are going to put hydrogen peroxide inside this funnel. Make sure, this is cork, right? Make sure tied up. So none of the gas, because I'm collecting the oxygen gas, right? None of the gas will escape from this bottle. First thing is to collect this tray. I'm collecting oxygen gas from here, right? So there has one hole in here from where I'm going to collect the oxygen gas. You see the pipe is connected with this. So I'm collecting oxygen gas from this hole. Okay. This pipe should be downward to the sink. Otherwise, your station will be wet. Okay. I'm collecting tap water here. That's enough. We need actually 5 bottles to collect my oxygen. So I have already here. I make it sign that which I'm going to use for the part 3. Okay. So first I have to fill it out with the water. All the way up. Okay. I'm just keeping it here. So later I will need it. Now the hydrogen peroxide, I'm going to pour it. Make sure you have to pour, not all of them you have to pour it together, because it may produce a lot of bubbles, right? I don't want much. A few of them. See, the bubble is coming up. Oh, okay, you can see. First, what I did is I don't want the excess air. The air could be contaminated with, the air is with nitrogen, oxygen, any gas with the air. So I want to escape from the air. Now make sure I don't have any air inside. Okay, what I'm going to do, I'm collecting the oxygen gas. Oxygen density is less than water, so oxygen gas coming up. So on the top portion will be oxygen gas, and at the bottom I have some water. I need some water because I'm doing pH test for part 3. Okay, so here is no bubble. I don't need any bubble, no gas, nothing. Okay, so I'm doing it again. As I'm collecting the oxygen gas and I need to cap it, I just put it inside. It just stays here. Okay. Now very little. See, the gas is coming. It replaced the water and taking place the oxygen. So just collecting oxygen, I'm preparing for the second one. Make sure no bubble. Okay, so I need a little bit water, so I can close my bottle. Move your bottle vertical way. Okay, now I'm going to collect the other one. Now we are doing the part 3 where we are making the oxides. So we have like different elements: sulfur, phosphorus, iron. I think there has lead, magnesium, and carbon. So all of them, we are going to do the same procedure. Like each element, we are taking on in the spoon. We will burn it, and after we burn it, we will check the flame. Actually, we will check the flame changes. So after burning it here, and when we contact with the oxygen what we collected in part 2, so flame color when it is burning and when we contact with the oxygen. So we are going to check the color changes, and also what we're going to do like part 3 is actually we are preparing for part 4, which is pH test. So making it oxides for each element, let it stay to contact with the water what we have inside, because for pH test we need some water. So element react with the oxygen, we will get the oxide. That oxide react with the water, and that water we will collect for part 4 to check the pH test, if it is acidic, base, or neutral. Okay, so that's our objective to do the lab. First we take sulfur. When you burn it, make sure you are all the way up. So okay, it's burning. So you can see that there is no burning, no flame change, right? We are putting it here. Whoa, wow, there is a color. So sulfur loves oxygen. When it was with the air, doesn't make that much flame, but when it's contacted with the oxygen, it has a bluish color. Okay, so We are going to let it be there. So sulfur with the oxygen make it sulfur dioxide or sulfur trioxide. We don't know. I mean, both of them it can produce. I'm not going to show you all of them. You can do it by yourself. It's the same process. Take the element in the spoon, burn it here. Make sure you change. You see the color changes. So in the air, what's the flame? What's the color of the flame? And when it contacted with the oxygen, what kind of flame it produces? And after you get the flame, I mean the element contacted with the oxygen, you get the oxide. Let it be, stay, because this oxide will react with the water, and we will going to use this water for the pH test. Now we are going to do part 4, which one is pH test. These are all the original solution. So these are basically from the pure element which react with the oxygen, gives us oxide, and this or that oxide react with the water, because in a jar we have little bit of water. We need this water because of doing this pH test. Okay, so now we are going to do the pH test for each of them. We have sulfur, phosphorus, carbon, iron, and magnesium. So sulfur, check. It's totally clear, right? Now we are going to use 2 indicators to doing the pH test. One is universal and another one is phenolphthalein. Universal, it will help you to indicate like green color. If it has the green color, that means it's the neutral. That means it's not acid, it's not base. If it is going from green to pink, that means it's basic. If it is going from green to red, so that means it's acidic. So let me see what's going on in here. So first we are trying the sulfur universal indicator. I'm not going to use much, just only 2 drops. Okay, so for your 1, 2, okay, not too much. You see, it comes pink, right? It was totally clear, it comes pink. So you will decide what it should be, acid or base. Next one is phosphorus. So this one is a little bit cloudy, it's not that clear. It's a blackish red type of color. Indicator, 2 drops, 1, 2. Wow, it's kind of red. So sulfur is light pink. This one is kind of red. Okay. The next one, carbon. It's kind of greenish black. Indicator. One. Violet, right? Kind of. Now, iron. Very clear. This is more greenish. That means it doesn't have any reaction. I said that green has no, it should be neutral. This is a greenish iron. If you see, it's not that much clear, but it's a little bit foggy. As this is white background, that's why. But if you see in the black background, it's kind of cloudy. This is magnesium. It's also kind of violet, but like bluish. It's kind of bluish. Okay. So now see all of them with the white background. So this is green. Which one is iron? I have carbon. This is magnesium. This is phosphorus and this is sulfur. Use the second indicator, which one is phenolphthalein. Phenolphthalein color changes only from pink, is going to the pink. There is no other color. So if it is pink, that means it's a basic solution. Okay. It's the same sulfur, which is clear. Okay. 2 drops. 1, 2. No color change. That means it should be acidic. This is phosphorus. One, 2. No color change. Same. This is phosphorus. Now this is carbon. Yeah, carbon. Whoa. This is color change. Pink color. That means it's basic solution. Now iron. Totally clear. No change. So universal indicator also give me the same kind of. Okay, this one is magnesium. Also, this one is pink. So phenolphthalein indicator changes the color to the pink. Now come to the reactions. As we did, this one is when we did the reaction inside the hood. So we have, these are all the pure element. So sulfur react with the oxygen, which one was in a jar, make it sulfur dioxide. Sulfur also can make with the oxygen is a sulfur trioxide too. Phosphorus react with the oxygen is tetra phosphorus dicoxide. Magnesium with the oxygen, magnesium oxide. Iron with the oxygen, iron 3 oxide. And carbon with the oxygen, make it carbon dioxide. So these are all inside the hood. So when we burn the pure element and then put it inside the jar, this compound produced, and then we let it set to do the reaction with the water, because inside the jar we have water too. So then this sulfur dioxide, sulfur trioxide react with the water. So sulfur trioxide react with the water, produce sulfuric acid, which one is strong acid. It may also react with the sulfur dioxide and can produce sulfurous acid, which one is weak acid. Phosphorus, tetraphosphorus dicoxide react with the water, produces the weak acid, phosphoric acid. Magnesium oxide react with the water, magnesium hydroxide, which one is slightly soluble. So you can see little bit solid thing. Iron 3 oxide react with the water. There is no reaction because the iron is solid. It doesn't it's not soluble in the water. Carbon dioxide with the water produce carbonic acid. Carbonic acid is a weak acid. So these are all you can see carbon, phosphorus and sulfur. So magnesium and iron, these two are metal. So metal, when they react with the water, make a basic solution. And which one is the non-metal? So sulfur is also non-metal. So non-metal element, when they react with the water, make it acidic. And which one is the metal? Metal react with the water, make it basic solution. And as I said, universal and phenolphthalein, the two indicator we use. If you see your color is from green to red is acid. If it is going to green to pink is basic. And phenolphthalein, if it turns to the pink, so that means it's a basic solution and weak acid. Thank you. So in this lab we used two indicators. One is universal and another one is the phenolphthalein, right? So universal indicator, how we know we did the lab, right? So pH color, when it is like green color, it's like a neutral. So that means we don't know yet it has the acid or base. As we are using how do I know when we do the universal indicator? If my color has changed to violet, that means it's a base. And if my color has changed to pink to red, it's getting acid. Okay, so that means green, blue, then violet is going to base. From green, it is getting to pink and reddish. We have the acid. That's how we know. And another one is we use the phenolphthalein, the pH. So when you use the phenolphthalein, there is no color. It should be like water. There is no color, right? So that's why I did not use any color here. So that means it's a neutral. But the phenolphthalein, it just only can tell you if it is base or getting pink. So if you get a color pink, Only one color you will get when you use the phenolphthalein. If you get the pink color, that means it's a base. If you have no color, that means it's acid. That means the color doesn't change. I mean, whatever you started is the same remaining. That means it's acid. If the color change, just only one color it will be changed if you use the phenolphthalein. It should be pink. If it is pink, then it's base.